Hello, PreCalc. We are observing this video on the 11th, 12th, or 13th, the weekend, and we are studying the law of sines, but just before we get back into that, let me give you the equation that I want you to practice for Monday. Remember, I'm going to keep, even though I'm doing a new topic, I'm keeping solving trig equations fresh because some of us are still working on those in our classwork, and we need to have a major quiz or a little test on those before the holiday. So here's your equation for tonight. 2 sine 2x minus square root of 2 equals 0. And I want you to solve that, and whenever you solve a trig equation at the end of the story, you're telling me what x equals. So notice that I have given you no intervals, so I want the infinite number of equations. And notice the doubled argument here. There's a double angle in the argument there. So bring that in all of its glory with you on Monday morning solved. All right. Let's do a practical problem using the law of sines. The law of sines, you'll recall, is side A, little a, over sine of angle A. So we have A over sine A equals B over sine B equals C over sine C. I wonder why they call it the law of sines. Well, we're going to use that today in a practical problem because poles, they're not straight. So let's draw a pole. If it was straight, it would look like this, exactly straight. But it's going to be tilted toward the sun, and that tilt is 8 degrees. So we have a pole that's tilted toward the sun, and the sun is right there. And it's tilted toward the sun 8 degrees, and the shadow that the pole makes from the sun is going to be right there. It's going to hit the ground right there. And that shadow is 22 feet long. And the angle of elevation from the ground to the top of the pole is 43 degrees. So I want you to find the length of the pole, the height of the pole. So we have enough in our law of sines arsenal to go ahead and solve this. And by the way, put the law of sines in your comp book and in the formula part of your comp book. So let's do that. All right, when we have the law of sines, we are going to put A's, B's, and C's in. So I just chose arbitrarily A, B, and C. And the part that we're looking for is B. So it's, remember, big B, angle B is across from side B, indicated by a lowercase b. So I'm looking for little b, so I'm going to circle it. And maybe little a will come out to play, but we'll see. So, do we have enough to use the law of sines? The law of sines requires that you have a pair. A pair is a known side and the angle opposite. Do you see a pair in the air? I see a pair, and that is this angle and the side opposite. Oh, that's not a pair. It is a pair, but it's not known. Is there a pair? How about this? Oh, no, we don't know either of those. Well, it must be this one. Oh, no. So why did this come out to play when the law of sines doesn't even apply? It does apply. It doesn't apply right this second, but in 2 seconds it will, because we know this angle and we know part of this angle. Couldn't we easily get this angle and then have a pair? I think so. So if this is 8 degrees, notice this vertical that the pole would have been is 90 degrees with the ground. So this whole angle must be 98. So if this is 98 and this is 43, we know that all angles and triangles add to 180. So when you subtract from 180, 98 and 43, you come up with a 39. So now, do we have a pair? Yes, the pair is this angle at this, no it isn't, the pair is this side and this angle. 39 degrees is known and the side opposite is known. So I'm going to use C over sine C, and the part I'm looking for, I want that in my proportion, B over sine B. Alright, I picked those. So little c is 22, sine of c is sine of 39, and little b is what we're looking for, and big B is sine of 43. Alright, so how do we solve that? We're going to take that and multiply both sides by sine of 43. When you do that, it'll disappear from this side and appear on this side. So sine of 43 will come over here on the left, and 22 is still here, and underneath is sine of 39, and left by itself is what we're looking for, side B. So all you have to do is tippy tap and sine 43 times 22 over sine of 39. So when you do that, do you not get 23.84? Alright, and that was in feet. Alright, I'm not going to show you very much this weekend edition because I don't think our classwork has caught up to the law of sines in every case. So I don't want to go steaming ahead of our classwork. So I'm going to stop there, and that's another example of the law of sines, this time put to a practical example. So I hope you're having a good weekend and that this has added to it. Alright, till Monday morning, bright and early in math class. We'll see you then.